Hello there. Today we are going to continue with our work with equations. So far we have done one-step equations, two-step equations, multi-step equations, equations with distributive property, combining like terms, all of those sorts of things. And as mentioned the other day, now we're going to add a new part to our equation solving skills, and that is how do you solve an equation with variables on both sides of that equal sign? All right. On the first page of the notes that you should have in front of you, there are 3 problems that are completely solved for you already. I would like you to pause the video and then please read through all the explanations, the directions, and take a look at every equation, how they manage to get the variable from the one side of the equation to the other side. All right. So take a minute to read through those. Then you can join me back and we'll work through some more problems together. All right, welcome back. I hope you read through those first examples. And now let's try some here. As it says on the front, and if you take a look at the examples that you see here, as mentioned, you will see that we now have variables on both sides. In order to get the variables together, we're going to use those inverse operations to, again, move something from the left side to the right side. Again, it doesn't really matter what side you get the variable on, as long as you get them all on the same side. As always, sometimes one way is shorter than the other, so we'll kind of take a look and see what you want to look for and how you can do this. Okay, so starting with number 4. Over on the left side here, we see a 5x, and then over on the right side, we see a 7x. All right. So similar to what I have done before, you guys, I'm going to go ahead and draw that little line through the middle there. Remember, whenever we're doing something to one side of the equation, we have to do the same thing to the other. So just like before, we could, plus 5, or plus 7, or whatever. We can do that with the little terms that have variables as well. Okay. So in this problem, the shortest way for me to do this problem would for me to get these minus 7x that you see here. I want it to move it from the right side to the left side. So since this says minus 7x, we are going to go plus 7x. We're going to line it right underneath the 7x. We go to the other side, we put plus 7x as well. All right. Then we can go ahead and we combine our like terms. We can add the 5x and the 7x. So 5x's plus 7 more x's means now on the left side, we have 12x. Put my equal sign back in the middle. A negative 7x and a positive 7x. You can cross those out if you like. And then we're going to bring down the 6. All right. So once we move that x together, now it looks just like the other problems we've been working with. And now our goal is to find or solve for x. That means we need to take care of this 12. Again, inverse operations, this means 12 times x. So to undo that, we want to divide by 12. We want to divide by 12 again on both sides. All right, so my answer, we have x equals, we have 6 over 12. So if you go ahead and would type that in your calculator, 6 divided by 12, your calculator will probably spit out a decimal. So we could go with x equals 0.5. If you wanted to leave it as a fraction, you could do that as well. Like I said, most calculators will give you a decimal, but as a fraction in simplest form, we could say x equals 1/2. All right, and that is all for that one. Okay. Looking at number 5, looks a little bit longer. We do see parentheses in this one. So as we discussed the other day, whenever we see parentheses, we do want to go ahead and distribute that first before we do anything else. We do see, again, here's x term on the left. We have an x term here on the right. We also have another x term. So we might have to do a couple different things in this problem here before we can actually get going. All right, on the left side, I'm just going to copy down what that says. Can't do anything there yet. We're going to do a little bit of work on the right side. This x, I'm just going to copy that down for a second. The -4, again, this little negative sign is with the 4. This is where we're going to do our distributing. So we're going to take that -4 times the 2. We're going to take a -4 times the x. All right. So -4 times 2 will give me a -8. So I'm going to write down -8, -8. Then we're going to take a negative 4 times a x. That would be a minus 4x. All right. Now that our parentheses are gone, we can still see that we have multiple x's over on the right side. So here we would combine our like terms just like we did the other day. So again, remember when you're combining your like terms on the same side of that little line that I drew, you just do exactly what it says. I'm going to go ahead and pencil that little 1 in front of there so we don't forget that as well. So this means I have 1x and I'm going to subtract 4 x's. So if I have 1x and I try to subtract 4 x's, I now have negative 3x. I'm going to copy down my minus 8. All right, and then on the other side, we have 7 minus 3x. So now we are to the point where, again, we can see we have x's on both the left and the right, and I want to get them to the same side. Again, doesn't matter which way you want to move them, just pay attention to where that equal sign is and make sure that you're doing the same thing on both sides. All right. So I'm going to go ahead and take these right here, this minus 3x, and I want to move it over to the other side. So again, I'm going to do my inverses. If this says minus 3x, I'm going to go plus 3x, and I'm going to go plus 3x. All right. We're going to go ahead and bring down our 7. Now over here, we have negative 3x and a positive 3x. So this would actually be 0. So I'm going to go ahead and cross that out. We have our equal sign right here, putting that back in the middle. On our right side, we also have negative 3x and positive 3x. All right, I'm going to cross those out as well. All I have left over here is negative 8. All right. This is kind of different if you compare it to what we did for number 4, because if you notice, we don't have any x's left anymore. All right, so all it says is 7 equals negative 8. All right, so we're going to leave that there for a minute, and we're going to take a look at these because you can see a little, what are we thinking about here? What's going on here? What happened? What do we do when we have a problem like this? All right, so we're going to leave that there for a second. We'll come back to that. Let's take a look at these two, and then we can discuss what happens or what do you do when your variables completely cancel out like they did in number 5. All right. So let's see, in number 6, looks like we have some more distributive property. So here we go. We're going to go 6 times 4x. So 6 times 4, 24. Put your x back on. We have 6 times 5, and there's a negative sign in front of it. That means we have minus 30. All right, and then on the right side, we got really nothing we can do over there. There's no distributive property. There's no like terms or anything. So I'm just going to bring that down to the next line here. All right, so that's what we have. Again, we still have x's on both the right side and the left side. So let's get them together like we did up there for number 4 and like we tried to do over there for number 5. We're going to do the same thing here. These 24 x's are positive. So again, that means I would want to go minus 24x minus 24x on the other side. Always doing the same to both sides of that little line there. 24 x's minus 24 x's, that's now 0. We have a negative 30 here. Have our equal sign in the middle. 24x minus 24x, that's also 0. We have a minus 30 here. All right. So similar to number 5, we can see that, again, there are no more x's. All right. It's a little different than what we have up here, though, because if you think about this, this says 7 equals negative 8. That doesn't make a whole lot of sense. Here, we have negative 30 equals negative 30. Okay, that makes sense. Negative 30 does equal negative 30. So that's okay, but let's figure out what that means. We're going to do number 7. Then we'll take a look at what's written on the bottom of the page. All right. Let's see. For number 7, looks like we're going to have to distribute on both the left side and the right side. Take care of these parentheses. So that is step number 1. We're going to take 5 times 3x. So 5 times 3, we got 15. Put your x back. We have 5 times 5, and there's a plus. So that means we're going to go plus 25. Okay, so distribute on the left side. All done there. Then we do the same thing. We're going to distribute on the right side. 3 times 5x. So 3 times 5, 15. Put the x back in. And then we have to go 3 times 1, and it's a positive, plus 3. Okay, again, our goal, we still have variables on both sides. We want to get all the variables to one side. Again, we could move these 15 to the left, or we can move these 15 to the right. All right, so sometimes you have some choices. I personally usually like to go to the left. All right. Similar to number 5 and 6, you guys, look what's happening here. 15x minus 15x. X's are completely gone. Bring down our 25. Keep our equal sign in the middle. 15x minus 15x. Again, those are gone as well. And we have 3. Okay. So if you look at the last couple problems we did, there's kind of 2 things that can happen. All right. These 2 problems kind of turned out the same in that, again, the x has completely disappeared, and we have this, 7 equals -8. That is not true. 7 does not equal -8. Here we have 25 equals 3. That's not true either, okay? So both of these gave us a statement that, is not true, all right? If we look at number 6, though, we have -30 equals 30. That is true, okay? So what does that mean as far as when we're trying to solve an equation and find out what is the solution? In our problem up here for number 4, our solution, we would say, was x equals 0.5 or x equals 1/2. All right. For these problems, it can be a little different. And let me slide up to the bottom of the page here. All right. So you can see kind of on the bottom here what that means. All right. So in our 2 examples, when you solve an equation, you end up with a true statement. All right, so here's another example, you guys. They solved their equation. They got all their x's over to the left, and all they ended up with was 6 equals 6. This is true. So what that means is there are going to be infinitely many solutions. All right, we describe that as being all real numbers. That means any number in the world that you can think of, if you were to substitute it into these 2 little spots where it says x, this will always be a true equation, okay? So we could pick 5, we could pick 100, we could pick 1,000,000 if we wanted to. As long as you put it in here, it will always give you a true statement, okay? So we say many solutions, infinitely many solutions, okay? Whatever number you want, okay? The other situation was the other one we looked at. So again, here's another example. This time you can see they solved their equation. They got all their x's together. The x's canceled out, and now it just says 6 equals 4. Okay, 6 does not equal 4, you guys. That is not true. So that means there are absolutely no solutions to this problem. All right, there is no value for x that I can put into this equation where I would get a true statement at the bottom. Okay, so we say there's no solution. We also can refer to that as the empty set because there's nothing we can put in a set of numbers. There are no numbers. All right. So those are the 2 kind of, I'm going to call them weird situations if you want. So if your variable completely cancels out, those are the 2 things that you want to look for. Did you end up with something that was true when you got to the bottom, or did you end up with something that was false? All right. All right, I think we probably have some more examples. Let me see what we got here. Oh, there's more. All right. Oops. Yeah, I don't give you my answers yet. All right. So let's see. We have number 8 and number 9 on the page here. Again, I would like you to pause the video for a moment and see if you can go ahead and do, oops, I'm not, so that's number 8 and number 9. Sorry, let me slide it down. All right. So pause your video for a minute. Go ahead and see if you can solve number 8 and number 9. All right, and you can come back in a minute and you can check your answer to see how you did. All right, welcome back. All right, so this is what happened when I solved number 8 and number 9. Again, similar to the ones we just did a little while ago, you guys, we do have the variables on both sides. So in number 8, I went ahead and subtracted the 2x to move it over. And similar to what we just talked about, this is kind of one of those situations where you'll notice the x's completely disappeared from my problem, and I ended up with 5 equals -3. Again, 5 does not equal -3, so I'm going to go ahead and I'm going to write that there is no solution to this problem. All right. If you look at my work for number 9, again, please compare it to your work. Make sure you check all your signs, check your distributive property. Make sure you're not making any mistakes in there. Again, we got x's on both sides. I also did combine my like terms here on this left side here. I took the +3 and the -5 to get that -2. Again, it's just easier if you combine your like terms before you start trying to move things from the left side to the right side. And then again, I subtracted 3x from both sides. So I went -3x minus 3x. And again, in this one, you can see that I did end up with -2 equals -2. That is true. Okay, so again, when that happens, you guys, that means that we will have infinite solutions. So like I said earlier, that means every number you can think of would work in that equation. All right. All right, let's see what else we got here, you guys. We got a couple more here. Number 10 and 11. All right, again, why don't you pause the video, see if you can do those two problems, and then come back in a couple minutes and compare your answer. All right, welcome back. This is what I ended up with for number 10 and 11. So you can see for these two problems, we did have just one, I'm going to say kind of normal, regular situation. We did, again, get our x's all to the same side. So I went -6 minus 6. All right. And again, like I said, you can go to the left or to the right. This time I decided to go to the right. I personally like to keep x positive if I can. I just think it's easier. You could also go -8x over to this side if you like. So like I said, always just keep track of where that equal sign is. Make sure you do the same thing on both. All right. Since I did move my x's to the right, that means I want to start moving the numbers away. So you can see I went +13 to get my 20. And then my last step, this is 2 times x. Again, divided both sides by 2. So my one solution for this one, we do have x equals 10. For number 11, we had to do some distributive property. Again, there's those parentheses. You can see I went 6 times x. I went 6 times 2, and it's positive. Over here on the left, I also, again, combine some like terms, do exactly what it says. That's a +12 minus a 4. That gave me a +8. All right. This one looks like we only have variables on the left, so we're pretty much good to go. Move the numbers away. I went -8 minus 8. Over here on the right, that gave me -18. 6 times y, again, we undo that, divided both sides by 6, gave me an answer of y equals 3. All right. And again, at any time, you guys, if you need to stop the video so you can write stuff down, please do so. What do we got here? Looks like we got one more. All right. And no, let's go ahead and I'll do this one together with you guys. This one looks like we have 2 different distributive properties. Looks like we're also getting a decimal here. So this is, let me explain my steps here. You can do it along with me. We have 4 times 2x, 8x. We have 4 times a -8, -32. There's my equal sign. We're going to distribute on the right. 3 times 2, 6. 3 times a -3x, that would give you -9x. All right. Again, I've got x's here and here. So pick a side. Looks like I wanted to move these 9 to the other side. This said minus, so I did +9x, +9x. Again, make sure you're lining it up under its like term. We can't do it. We can't add it onto this number at all here. So line it up underneath the x's so you can see what you're doing. 8 plus 9, that would give me 17 x's total. All right. Since my x is on the left, now I want to move the numbers away. So here we go. We had a minus 32. We go plus 32 plus 32. That looks like it gave me 38. This is 17 times x. Divide both sides by 17. That gave me an answer of 2.2. All right. Looks like we got one last example. So again, we're going back to some of the geometry things that we had talked about in our last unit. The other day when we were working with our equations, we did things where we added up our linear pairs to equal the 180 or our complementary angles to equal 90. In this particular picture, these are our vertical angles. And again, our vertical angles are congruent. So since we're talking about equations where we have variables on both sides, you can see here, what we're going to do is we're going to take this vertical angle up here, and it will be congruent or equal to this angle that you see down here. And when we set that equation up, you can see that we will end up with an equation in which we have variables on both sides. All right. So we have the 4x minus 6, that's my one vertical angle. We have the 2x plus 60, that's my second vertical angle. We put our equal sign in the middle. Those vertical angles are congruent. So now we need to decide how we want to, or where we want to go with our x's. I'm guessing I probably subtracted the 2 x's. I like to keep x positive, so minus 2x minus 2x. Again, see how I lined it up underneath the x's? We can't subtract it from the 6. All right, so 4x's minus 2x is 2x. We're going to bring down that little negative 6. We bring down our equal sign. 2x minus 2x would be gone from the right. We bring down our 60, it's a positive. All right. Now we have the x's on the left. We got to start moving the numbers away. So I went plus 6, both sides. All right. So then we have 2x equals 66. And lastly, we divide both sides by 2. All right. Anytime we're doing the geometry problems, you guys, I would like you to also take your answer and find the measure. So this is where I'm going to get my calculator, you guys. We're going to take our 33 and we're going to plug it in here. So I'm going to go 4 times 33 minus 6. We're going to go ahead. We're going to write that right up here. This would be 126 degrees, which again, that makes sense. Looking at our picture, we can tell this is obtuse. It might not be exactly 126, but we can tell at least it's obtuse. All right, then we're going to take our calculator again. 2 times our 33. 2 times 33, and then plus 60. All right, and if we did this right, we should get 126 again, because again, our vertical angles should be congruent, and they both turned out to be 126. All right. So there you go. I think that's all I have for you there as far as your examples. Once you are done with all your examples, you should get a homework assignment. So a few more for you to practice on your own. Probably looks something like this. Algebra 1, solving equations. We have variables on both sides. We got 10 problems with some little vertical angles on the bottom. All right. So good luck with that. And I'll see you again next week. Bye.